The first project that I'd like to touch on is the Victoria Park Pavilion, which is a single-story park building for the local outdoor skating rink run by the City of Edmonton. It's semicircular in shape, which is achieved by these glulam frames every 4.5 meters or so. The architects on this one was Raylene Hill out of Nova Scotia. What's really unique about this project is the GLT decking, which spans between those frames but also wraps down the walls, creating a warm and inviting space for the skaters. I was involved in this project from early on in the schematic phase, all the way through design and construction to the completed building. It was one of my first projects where I was introduced into heavy timber design. So next up is the Okanagan College Trades Building, which is a fairly substantial $33 million renovation and addition to the existing trades complex built back in 1965. The three-story addition is largely a standard two-way concrete flat plate with concrete columns and stair cores. The roof of the main atrium space has these V-shaped columns with GLT panels over that, and the corridor link which connects the addition to the old shops and classrooms is a similar style. There were very challenging sustainability targets of LEED Platinum and Living Building Challenge on this project. And my involvement started early on in the schematic phase, all the way through design and construction to the completed building nearly 3 years later. This was really my first substantial project to run as a building engineer, and I was heavily involved in the design and construction, and it was a real learning curve. So next up, I'd like to discuss the 18-story Brock Common Student Residence building here at UBC. When completed in summer 2017, this will be the tallest wood building in the world at just over 53 meters tall. The architects on this one are Acton Austri out of Vancouver and Hermann Kaufmann out of Austria. The total project cost is about $52 million. So the building's 18 stories total with a prefab steel roof, 16 floors of two-way point-supported 5-ply CLT panels, and that all sits on a concrete transfer slab at level 2, which opens up the ground floor space. There's 2 full-height concrete cores, and those provide the lateral stability for the high seismic we have in Vancouver. So the real intent of this project was to create a mass timber building solution that was on par with the unit cost of a concrete tower. The aim was not to have another expensive pilot project, but rather one that was cost competitive and could demonstrate to developers that mass timber can and should be used on a larger scale. First and foremost, the design intent was to keep the structural system as simple as possible. We wanted to create a prefab kit of parts that could be installed quickly and easily and basically be put in like large-scale Lego. The really unique thing about this project is actually the floor system. So by taking advantage of the CLT's two-way spanning capability, we could really get rid of all the beams within the building and create a clean, point-supported surface for mechanical distributions and reduce the overall structural depth. In point-supported CLT, you get really high rolling shear stresses at the supports, which is where those fibers want to roll across each other. There's limited research on that right now, so we decided to do 18 full-scale load tests to verify our assumptions. Very interesting failure patterns that happen near the supports, and the panels certainly shed some load once the elements failed and it sort of propagated through the panel. Another unique design item is the axial column shortening. We ran many calcs to try and best estimate the realistic values of shortening and ultimately decided to mitigate those by adding steel shims at the column-to-column interface. We also completed a 2-story mock-up of the structure last summer. We tried out multiple connection types and got feedback from the timber installers. I think it was a really good experience, and we made a lot of improvements to the design after that. Currently we're around level 8, and the concrete cores are jump forming their way up. This May the towers will be topped off and the wood will arrive on site. I've been involved in this one from the start, mainly working with the project engineer here at F&E. Learned a lot on this one, and it continues to be really rewarding. So lastly, what does structural engineering mean to me? Well, first and foremost, it means creative expression. Ever since I was a boy, I've been building things, and that evolved into a real passion for woodworking and furniture making. And as engineers, we get to take that practical building experience and mesh that with math and science and find creative solutions. I think that's a real treasure to be had.